So let's look at the sine and cosine formula. So far we've talked about the right angle triangle and in which we define the properties or the relationship between the lines and the angles using SOHCAHTOA. But now I want to generalize this idea to triangles that are not right angle triangles. I'll make use of the sine and the cosine formula. So let's start out with the sine rule. So let's look at a triangle ABC, and as we've defined our convention before, the side opposite to angle A is written as small letter A, that opposite to angle B is denoted as small letter B, and the side opposite to angle C is denoted as small letter C. So when you have a triangle with these corresponding lengths and angles, we can write that A over sine A is equals to B over sine B over C over sine C, and you can write the reciprocal. So what does this do? So by just knowing the angle of one side and the length of the corresponding and the length opposite to that angle, and by knowing the length of any other side, I can find the angle. So what it means that I can equate any two of these equations. So I can write out, say, A over sine A is equals to B over sine B. I can also write out that what A over sine A is equals to C over sine T. I can also write out that A over sine A or B over sine B is equals to C over sine C. So depending on what side and what angle I'm looking for, any of these combinations, I can apply them to find any of the unknown sides. So let's see what I'm talking about. So in this next example, we are told that in a triangle ABC, so we have a triangle, and I'm just going to sketch that out roughly. So you have a triangle ABC. So I'll call here A, and here B, and here C. We are told that the angle A is 29 degrees. So this angle here is 29 degrees. We are told that angle B is 36 degrees. The angle here is what? 36 degrees. And we are told that small letter B, so the side opposite to angle B is small letter B. So this side B is equals to what? 15.8 centimeter. We are now asked to find small letter A, which is the side opposite to angle A. So this place is small letter A and this place is small letter C. So I know the side B and the angle B, and I'm looking for the side A, and I know the angle of A. So I can write out that what? That B over sine B is equals to A over sine A. And when I do this, what is my value of B? My B is what? 15.8 over sine, and my angle B is what? 36. Is equals to, my A is what I'm looking for, A over sine, and my angle for A is 29. So this means that what? A is equals to 15.8 times sine 29 over sine 36. So when you punch this into your calculator, you have 15.8 times sine 29 will give you 0.4848, and sine 36 will give you 0.5878. So that gives you your A value when you punch this to be what? 13.03, and the unit is going to be in what? Centimeter, because that is the unit of length here. So the distance A is what? Or the length A is what? 13.03 centimeter. So now let's talk about the cosine rule. And the cosine rule is really an interesting rule, and I want you to pay close attention. So let's assume we have a triangle and our convention remains the same. The side opposite to angle A is small a, side opposite to angle B is small b, and the side opposite to angle C is small c. So we can write that A squared. So this is also a generalization of the Pythagoras theorem. We have like A squared is equals to B squared. So if I'm looking for this length A squared now, is equals to the sum of these other two sides square, B squared plus C squared, then minus 2 times the other two sides, B times C, then times cos A, times cos of the angle. So you just need to memorize one of these formulas, and if you memorize one, you can easily write the other out. So the thing to put at the back of your mind is that the side they are looking for squared is equals to the sum of the square of the two other sides minus 2 times the product of the two other sides, then times the cosine of the side they are looking for. So in this case now, I have B squared is equals to A squared plus C squared minus 2AC cos B, and I have C squared is equals to B squared plus A squared minus 2AB cos C. So the formula you use depends on what is unknown, what is known and what is unknown and what you're trying to look for. So let's try to walk through some examples. So here we are told that in a triangle ABC, A is equals to this, C is equals to this, and B is equals to this. Find length B, then angle A and angle C. So to start out, I'm just going to draw a rough sketch of the triangle. So any triangle will suffice. So I have a triangle ABC, AB and C. I'm told that small letter A, or the length A, which is the side opposite to this angle A, is equals to 6.7. Side C is equals to 2.3, and angle B, this angle over here, is what? 46.6 degrees. Now I'm told to find what? Length B. So I'm looking for this length opposite here. So now if I write out my cosine rule in terms of B, I have what? My B squared is equals to what? A squared plus C squared minus 2AC times what? Cos B. So I can write B squared is equals to my A in this case is what? 6.7 squared plus my C is what? 2.3 squared minus 2 times 6.7 times 2.3 times cos 46.6, and that becomes 6.7 squared is what? 44.89 plus 2.3 squared is 5.29, then minus what I have here is what? 2 times 6.7 times 2.3, and cos 46.6 is what? 0.6871. Now when I add this together, I have B squared is equals to this plus this gives me 50.18, then minus this times this times this times this gives me 21.176. So I have B squared is equals to this minus this gives me approximately 29. So my B will just be what? Square root of 29, and the square root of 29 is what? 5.385. So that will be 5.385 centimeter. Or since the other lengths are in one decimal place, I can just divide it to one decimal place, and that will be what? 5.4 centimeter. So the distance of this length over here, B, is equals to what? 5.4 centimeter. So now we're going to find the value of angle A and angle C. And how do we do that? So first, I'd like to sketch out the triangle that we've got into. We have the triangle again. I'm just sketching it out so you can see. We have triangle ABC. I told that the angle here is 46.6 degrees. Length here is 2.3. The length here is 6.7. I will find the length here to be what? 5.4. So now I want to find angle A. I want to find angle C. So let's start by finding out angle C. This angle here, C. Now we know length B and angle B, and we know length C, but we don't know angle C. So we can apply sine rule. So writing our sine rule in terms of B and C, we have what? B over sine B is equals to what? C over sine C. Now I know what B is. I've gotten B to be 5.4. So I have 5.4 over sine, and I know that B is what? 46.6 is equals to C, which is 2.3 over sine T, which is what I'm looking for. So I can write that my sine T is equals to 2.3 times sine 46.6 over 5.4. So I have the value of what? So that becomes sine T is equals to 2.3. Sine 46.6 gives me 0.7266 over 5.4. And that is equals to what? 0.3095. So C becomes arc sine of what? 0.3095. And when you punch that into your calculator, you get 18.03 degrees. So the value of angle C here is what? 18.03 degrees. Now to find angle A, I know that the sum of angle in a triangle is equals to what? It's equals to 180 degrees. So sum of angle A plus sum of angle B plus sum of angle C must be equals to 180 degrees. Now I know my angle B and angle C. So my angle A plus my angle B is what? 46.6. I found my angle C to be what? 18.03 was equals to 180 degrees. So my angle A 46 point, so my angle A becomes what, 180, then minus 46.6, then minus 18.03. When I punch this into my calculator, I get my angle A to be what, 115.37 degrees Celsius. So the value of angle A is what, 115.37 degrees. So now I found that the length B is what, 5.4 centimeters. Then the angle C is 18.03 degrees and angle A is 115.37 degrees. Now let's look at another example that combines our knowledge of both sine rule and cosine rule. So now in this example, and also it combines the idea of bearing. So this is the example that I mentioned when I was talking about bearing that we're going to solve later on. But we didn't solve it then because we needed the idea of sine rule and cosine rule to be able to solve it. So we're going to look at it now. So now we're told that 3 times A, B, and C are situated so that AB is equal to 60 km and AC is equal to 100 km. The bearing of B from A is 060 degrees and the bearing of C from A is 290 degrees. Then calculate A, the distance BC. So the first thing we want to do is we want to sketch this out. And we're told that the bearing of B from A is 60 degrees. So the first thing we do is that we identify point A. So if I say this is my point A, I'm told that the bearing of B from A is 60 degrees. So I measure 60 degrees. So I have what, 60 degrees. So the bearing of B from A, so from point B now to A, is 60 degrees. And I'm told that the distance AB is what, 60 km. So the distance from A to B is what, 60 km. Also, I'm told that the bearing of C from A is 290 degrees. So I measure a bearing of 290 degrees now, and 290 degrees will lie in the fourth quadrant. So I have something like this, and I draw a line that moves up now, and this is my point C over here. And I know that the bearing here is what, 290 degrees. So now the first question asks me to find what, the distance BC. So when I draw a line from point B to point C, so this distance over here BC, I'm told to find this distance over here. So if you look at this carefully, I can find the angle over here. The angle over here. Now I know that the angle in a straight line, or the angle in a point or around a circle, is what, 360 degrees. And I'm told that the angle from this point to this line over here is 290 degrees, or the bearing. So the angle over here, or this small section over here, is just going to be what, 360 minus 290 degrees, and that gives me what, 70 degrees. So I know that the angle over here is what, 70 degrees. So the total angle for angle A now will be equal to what, I know that this small section here is 60, I know that this small section here is 70. So the total angle will be 70 plus 60, and that gives me 130 degrees. Now I'm told that distance AC, this distance AC here is what, 100 kilometers. So that here is 100 kilometers. Now I'm told to find this length CB. So now if I want to label it my normal convention, I know that the side opposite here will be small a, side opposite here will be small b, and the side opposite here will be small c. So now this is approximately a triangle, and I will draw that out again so you can see it clearly. A triangle as this, in which I know that this angle over here is 130 degrees. Then this is my point A. I'm told that the distance here is 60 km and the distance here is 100 km, and I'm told to find A. So now to find A, I know that what, A squared, using the cosine rule now, I know that what, A squared will be equals to B squared plus C squared minus 2BC cos A. So all that give me, I know that A squared now, my B in this case is 60, so I have 60 squared, and my C is what, 100 plus 100 squared, then minus 2 times my B value is what, my B value is 60, 2 times 60 times my C value is what, 100, then times cos A value is what, 130. So what does that give me? I have A squared to be equals to 60 squared is what, 3600, plus 100 squared is 10,000, then minus 2 times 60 times 100 gives me 12,000, and cos 130 gives me minus 0.6428. So a squared becomes this plus this gives me 13,600, then minus times minus gives me plus, and 12,000 times this gives me 7,713.45. So I have my a squared. When I sum this up, I get 21,313.45. This is 1 over here. So my a will just be the square root of what? 21,313.45, and that is equals to 145.99, and that is approximately equals to what? 146 kilometers. So the distance A, or the distance from B to C, is what? 146 kilometers. So here is what? 146 kilometers. So now we're going to move on to the B part, and the B part tells us to find the bearing of B from A. So to do that, I'm going to sketch out the diagram again. So to sketch out the diagram, then we know that we have at this point A here, we have a bearing of 60 degrees to point B over here. Okay, bearing is 60 degrees, and we know that from here again we have a bearing to point C, and we know that the angle there is what? So that it's 290 degrees. So that the distance here is 60 kilometers and distance here is 100 kilometers. Now this is my point C. Now the question asks me to find the bearing of what? The bearing of B from C. So in other words, what is asking me to find, if I am looking for the bearing of B to C, is this angle over here. So this angle over here, or let me mark it with another marker, this angle shaded by this green line over here. So now this is pretty straightforward. I know that this angle over here is what? This one to the horizontal line is what? 90 degrees. However, I do not know this angle, or this tiny angle over here, and that is what we're going to be trying to find. So now to do that, start out by saying, what is this angle over here? From our previous example, we found that the angle over here is what? 70 degrees. Now if we look carefully, you find out that this angle over here is alternate to this angle over here. So if here is 70 degrees, definitely here also will be what? 70 degrees. Now if I can try to find the angle that is in between here, what would that mean? That means I would be able to find, and I add it to this, to 70 degrees. That means I know the angle from this point over here towards this line over here. Now I know that the angle on a straight line is 180. So if I minus it from that, I'm going to get this angle that is shaded in green. So let's get started. So the first thing I want to do now is to find this angle that is within here, and that is what? Angle C. So applying the sine rule now, and I found this length here also to be what? 246 kilometers. So applying the sine rule, I know my angle A to be equal to what? 130 degrees, and I know the length A to be 146. And now I don't know the angle C, but I know that my length C is 60 degrees. So if I apply that formula in terms of C and A, what do I have? I have what? I have A over sine A is equals to C over sine T. So what does that become? My A is what? 146 over sine 130 is equals to, my C value is 60, the length over here, over sine T. So sine T will be equals to what? 60 times sine 130 over what? Over 146. And that will be equals to 60 times sine 130 gives me 0.766 over 146. And that is equals to, when you punch it in your calculator, 0.3148. So my angle C now will just be equals to arc sine of 0.3148, and that is equals to 18.35 degrees. So I know the angle over here now to be what? 18.35 degrees. So now if I know that the angle over here, so what I have now, I'm going to try to like zoom in on this so you can see it clearly. So you have this, so this is point C over here, so you have point C over here, and now you have two lines. You have this line over here, I have this line over here. What I'm trying to look for is this area shaded with green, this angle over here. Now I found this angle over here to be what? 18.35 degrees, and with our knowledge of alternate angles, I found this other angle here to be what? 70 degrees. Now we can see that this is a straight line over here, so the sum of this angle in green plus this angle over here plus this angle here must be equals to what? Must be equals to 180 degrees. So I can write out that what? I can write out that this angle over here, and let me call that x. Let me call it x. So I can write that what? That x plus 18.35 degrees plus 70 must be equals to 180. So x equals to 180, then minus the sum of 18.35 plus 70, and that is the same as saying 180 minus 88.35, and that gives my value of x to be equals to 91.65 degrees. So this angle over here is what? 91.65 degrees. So this angle over here is what? 91.65 degrees. So the bearing of point B from C, which is this angle over here, is what? 91.65 degrees. So to write it out clearly, bearing of B from C is equals to 91.65 degrees. So that pretty much sums up the idea of sine rule, cosine rule, and bearing. In the next section, we are going to be looking at some past questions to see how to apply what we've learned to solving practical questions.